to Chemistry Solutions. This is a GCSE revision video and it's taken from section 4.3 of the AQA syllabus on quantitative chemistry. The video is all about the calculations involved with gases. As with most GCSE subjects, you'll not be surprised to find out that there are some things that you've just got to learn. And these are called definitions. So here's a couple. Gas calculations, you must learn these. Equal numbers of moles of gases occupy the same volume at the same temperature and pressure. And the volume of 1 mole of any gas at room temperature and pressure, that's 20 degrees Celsius, 1 atmosphere, is 24 decimeters cubed. Remember, a decimeter cubed is just another name for a litre. And as with most things like this, there's a formula. So the volume of any gas at RTP, room temperature and pressure, is the number of moles times 24. So let's do a quick worked example. Calculate the volume of 0.25 moles of hydrogen at room temperature and pressure. The molar volume is 24 decimeter cubed. That just means the volume of 1 mole. So pause the video, work it out, see if you get it right. So volume is moles times 24, 0.25 times 24. The volume of 0.25 moles is 6 decimeters cubed. Let's take a look at a past paper question. Calculate the volume of 150 kilograms of chlorine gas at room temperature and pressure. The volume of 1 mole of any gas at room temperature and pressure is 24.0 decimeters cubed. The relative formula mass for chlorine is 71, and this is a 2-mark question. As is the norm with most calculations like this, we have to work out the number of moles of chlorine gas. And we do that using our formula triangles, Mr. Moles with the mass on his head. So our moles is the mass divided by the MR, the Mr. Now the mass is in kilograms, so we must multiply it by 1,000. So we have 150,000 divided by 71. And that gives us 2,113 moles of chlorine gas. Remember the formula from earlier on? The volume is the number of moles times the molar volume, the 24. So the volume of that gas is 2,113 times 24. So if we crunch that on our calculator, we get, rounding up, 50,700 to 3 sig figs. We would get 1 mark for working out the moles of the chlorine gas, and our second mark, that would be for working out the moles times the 24 and giving us our 50700. Let's look at another question. This one's a little bit more tricky, but it is a 5-marker. Iron oxide Fe2O3 reacts with carbon to produce carbon dioxide. The equation is 2Fe2O3 plus 3 carbons plus 3C goes to 4Fe plus 3CO2. Calculate the volume of carbon dioxide gas at room temperature and pressure that is produced from 40 kilograms of Fe2O3 using excess carbon. The MR, the formula mass for iron oxide, is 160. And the volume of 1 mole of any gas, room temperature pressure, 24 decimeters cubed. I use what we call this table method, and you may have seen it in other videos of mine. And what we need to do is look at the 2 compounds that we're looking at in the question, and that is the iron oxide and the carbon dioxide. So we put them down in their molar ratios. Down the left hand side we write mass Mr. Mole ratio, and we fill in any numbers we've got in the question. For example, the iron oxide was 40,000 grams because it says 40 kilograms, but we need it in grams, so we multiply it by 1,000. In most of these calculations we have to work out the moles, so we use our Mr. Moles with a mass on his head triangle. And we've got the Mr, the MR, which is 160 given in the question. So we're going to divide then 40,000 by 160. And that gives us 250 moles. Then we look up to the equation for the molar ratio between the iron oxide and the carbon dioxide, and you can see that it's 2 to 3. So for every 2 moles of iron oxide, we get 3 moles of carbon dioxide. So if we've got 250 moles of iron oxide, we must have 250 multiplied by 3 divided by 2, which comes to 375. And this is worked out from that molar ratio. So now we have the number of moles of carbon dioxide produced. So remember the formula at the beginning. The volume is the number of moles times 24. So that is 375 times 24, and that gives us 9,000 decimeters cubed, and that's for 5 marks. There'd be 1 mark for the mass of the iron oxide in grams, 1 mark for the moles, 1 mark for the ratios, 1 mark for the 375, and then the final mark for 375 times 24. So thanks for watching. You can do the usual clicks at the end here, and you can watch more of my videos from Chemistry Solutions all about chemistry calculations by following the links at the end of the video.